Hello and welcome. I'm Bill Wake. We're here working on an interpreter written for the basic programming language. It's written in Swift. We designed it with recursive descent parser, and we've switched over to parser combinator almost all the way. We've done all the statements, and we're working on the last bit of expressions. We've done all the layers down to factor, and then most of the way across, we're on the predefined function call, and we haven't touched the user-defined function call. Both those they have some special semantics to them, but both of them are also recursive. They all call expression back. So we've been working under a constraint that says old parsers can't call new parsers. So we wrote a new expression parser all the way down to factor. And if anybody calls recursively, like parenthesized or UDF, they call the old parser instead. So we had to keep the old parser around. Once we finish with these last two function calls, we can replace all references to the old parser with references to the new parser because we've closed the loop. And at that point, we've basically finished the substitution. We've got some other follow-up work to do, but we'll get there. And let's see, the other thing with this, the predefined one, it's got a P there. It's got to check parameter types. And the UDF, the user-defined function call, has to only take numeric types. All right, let's go to the IDE. Okay, and we left off, we ran parser tests, and some of these we can see something's wrong. Let's see, print char $4.0 is not equal to type string, so it's got the type wrong. And the reason the type is wrong is we got this form predefined function call that's supposed to do all the semantics. It doesn't do any checking. It just says, oh, you're good, and your type must be number. Okay, that's not going to suffice for us. We left off kind of in the middle of this. We've done the syntax part, which is the function name and the expressions in parentheses and expressions in a comma separated list, but we haven't dealt with this, or I'm not sure if we'll have to see if we need to deal with this, but we might need to deal with that too. Okay, so what happens is you've parsed the function call. You've got the name of the function in the token there, and a list of expressions that are the arguments, and you've got the remaining input. And your goal is to produce a parse result over tokens that returns an expression. So predefined is an example of an expression, and success is a parse result. So this one says you succeeded with this function, these expressions, and type number. We'll need to do some better checking than that. Okay, so let's just pull in these semantic things, and then we'll sort them out. Okay, we just gather, then we check the count. And we do a type check and a return. Okay. Let's see. So we have the token and the expressions. We basically look at the function. Type, is token result type. Okay. And then we assign here. Okay, the throw is not good for us. Okay, so the idea is the token type should be a predefined function, and its type should be function. If it's not, then we did something wrong. Okay, so equals types result type. Okay. Yeah, so the only way we get in here is if this is a predefined function, which should have the type being a function type. And that's not necessarily the case. Okay, so let's see. this throw, I mean, this really is a kind of can't happen thing. I forget what you say. There's a way to stop it. It basically crashes it, but we're willing to take that chance. What is that function? It's not halt or stop. I've even used it before. I gotta look it up. I don't know if I can. Swift function to. No, it's not assert, it's not stop, it's, let's see if we can. It doesn't sound like any of those. Fail. How about to crash on failure? Or is it a precondition kind of thing? Abort? Fatal error, that's what I want. Okay. Yeah. Okay, so preconditioned failure, that might be more accurate. Failure, and let's failure function, and let's put the name. And it's kind of a can't happen, but let's just make sure. Okay. All right. So we're getting the result type. That's the thing we need to put in here, not just number. What did I call it? Result type. Okay. Okay. Now here, this gets the function. Now we need to take the arguments. If this has fewer functions than arguments, we append a missing. So let's make this arguments. Var arguments equals expers, and then while expers count less than parameter types count, x arguments dot append missing. Okay, so we have arguments. Let's use arguments here and here. Okay, now this, we may need to rewrite this too. I think he's not quite. Let's try the other one. No. Okay. Where's type check? There it is. Okay. Yeah, this is, well, it assumes throw. I mean, it's... Let's duplicate the function. We're going to go down the whole path. Oh, that one's all right. Okay, yeah, let's duplicate this function. Or maybe I can just call it. Let's call it instead. We can clean up later. Okay, so we'll do catch and then handle it. Otherwise, we can return success. I suppose we can move that up here. And the error we saw, parser. Failure, well, we're going to do index of token and message. Okay, and then we got one more catch. Oh, this is dot error. And then we have to catch this sort of can't happen case. Okay. Try type check. Okay. All right. So we're enforcing a few things. Okay. One is we're looking up the function so we get the result type, and we're getting the parameter types so we can validate against them. So we're going to fill up the arguments. Maybe it makes sense to, yeah, I guess it's okay. Fill up the arguments, fill in missing arguments for any that are missing, do a type check, and then if it's successful, return predefined, otherwise return one of the two failures. I think that will do the job. I don't hear a fan, but I don't see any progress either. Why would that? Oh, sorry, I see the problem. Up, where'd it go? This while is not changing arguments. We're updating the arguments list, so it will never change once it's in there. Let's try again. It's probably an easier way to do that. Okay, 3 failures. Extra characters in line is not equal to type mismatch. Okay. Well, I've mentioned before, I'm willing to accept different messages, but this one seems a little too different. Okay, why is that not doing there? So what that tells me is well, it doesn't really tell me where the problem is, but I think what it's doing is probably matching square root and a string. I don't know. Are we getting into our function or not? That's probably the real question. So let's see if we get into form predefined call. If we don't, then the parser was failing. Oops. If we don't get into the call happens here after all the arguments have been processed. If we don't get into it, then we gave up on it before that. So that might mean our grammar is a little bit off. I don't think there should be an issue. I mean, it should accept this because like there are functions that take strings. Yeah, left dollar takes a string. Oh, here's a good one. Right, this worked. Okay, so let me stop speculating. Let's just run this test. See if the debugger hits there. Okay, let's look at token. Whoops. Okay, square root. That's expected. Okay. The function one value takes one argument of type number and produces number. Okay. So I think we should be able to get down here. Okay. So let's look at arguments. Should be our one expression, string X. Okay. Yes. Type check. Okay, let's step over that. Yeah. Okay, it should fail the type check, so that's okay. But what's the message? Type mismatch. Oh, this token may be a problem. It's the line number. Okay, so we need to work from the remaining. Okay, we know where we are. I think we can do remaining dot start index. -1 is the parentheses, so -2 is part of the expression. Okay. And this one, let's just do remaining. I don't think if it can't happen, it's probably not an issue. It will come back and fail somehow, but I think if it goes back to the beginning of the expression, it's still not a problem. Okay, we don't need token. Okay. It would be better if the arguments, it would be really nice if my expressions knew their location, but they don't. Okay, let's try this again. So I think it was maybe it's an interaction with the two parsers, because we don't really move forward when we parse something in a combinator style. You're not really you're sort of moving a pointer forward, but you're not committing to that location. Where in the recursive descent, it's guaranteed if you go down a certain path, you're either going to get the construct or get an error. Okay, let's continue. Okay, good. All right. I feel like it's clunky. I guess I don't think you can. What are we getting from token here? Let's find uses. Well, that doesn't help. Okay. Token here, token string as information. And that's almost a can't happen. I guess I'm wondering if I could turn this into the result type, would that be an improvement? It would take out one clause and move it into its own thing. All right, let's commit first. All right, so this is handle or new parser for predefined function call. All right, R2 convert expression to new parser, predefined function call, and user defined function call. We just did the first one. I guess last time we did almost all of them. Okay, so this is 22-18, September 6th, and convert expression predefined function call. Yes. Okay, so we've done that one. Okay, and then here, let's take this out. I guess I'll move it up in case we need it later. This gets a green check mark. Okay, we'll work on user defined. And let me just check. Let's find the reference to this. Okay. Yeah, so we got predefined call and factor parser calls it. Okay. And last, we need this one. Okay, user defined function call. All right, so I don't know, this abbreviation is, I'll say user defined call, user defined function call. Parser equals, okay. I was just there. We peaked at .fn. Okay, so we need to match .fn. And we don't care about it, but we do care about the next bit. Okay, so we get the token. That skips over the .fn. We want to make sure the next token is a variable. This is match.variable. And I guess it's got this error. All right, we'll need that variable. That's fine. Okay. We're pulling out semantically. Okay, then a left parend. Well, let's pull all this and I can edit it. Okay, so followed by, and again, we don't need to keep it, but we need the left parend. And then we need an expression. You only get one argument. Expression parser. Okay. And then we need, ignore this one again, match our right parend. Missing right parend. Then we do the functions. So this is form user defined function call. And it's going to look a lot like this one. Whoops. Like this one. I think down to that even. Form user defined function call. Okay. And I guess I'll just move this down where we're using it. Predefined, type check, user defined. Okay. So what are we keeping? Well, we're keeping this variable and we're keeping the expression, and that's what we're passing in. So token, and this is just a simple expression. You only get one argument for these remaining. Okay, so the token and the expression. Match variable. Okay, we need the parameter is the token.string. Okay, and then the expression. We do a type check. We'll just steal these two again. Capital D. Okay, so the type check, again, we'll put it on to catch. Catch parse error dot error. And I guess same reasoning, we'll ignore that and get a message. And otherwise we're doing catch, and this is return dot failure. Remaining dot start index, and okay. Now this one, let's see. We do a type check. Okay, I guess we just kind of similar to the other one, we'll just do a fail. Notice this type check is only passing one argument in. It only has one argument, so it puts it in an array, so it can just use the existing zip mechanism. Okay. Type check. The return's not quite right, but let's deal with the error. It's a failure. Dot failure. Main dot start index, again -2, because we're remaining is after the right parenthesis, so skip backwards, and we'll point at the end of the parameter and the message. Okay, and if it succeeds, we're returning a success with, well, this and remaining. Expected. Like I say, I just never know when you have to have those. Digital type string. Okay. All right. Given a token and expression, get the name of the function from the variable. It's really fn whatever. So it's fn a, fn b, and so on through z. Do we have to check more than that? Not really. Must have a letter after fn. Did we? Okay. I guess if you don't find the function, I guess it's a runtime error if you haven't defined the function. So, all right. Okay, we do a type check. The argument must be type check match number. I think this is, if that's the parameter, I think this is an argument then. I don't know, I try and use this consistently, but I'm bad at it. Okay. Well, this should still work because nobody changed the existing stuff. We need to pull this parser up. Okay, into our main parser. Predefined and user defined. Okay. And then factor should use user defined. Well, let's make that capitalized too. Okay. user-defined function call parser. Okay. All right, now we should be using the new one. Okay. New parser for user-defined function calls. We're moving pretty well here. Okay. All right. Now, okay, I think that covers this one. But we have a little work to do yet. We need to make the use the new expression parser everywhere. Eliminate all wrap old calls. Okay, that's going to be 2 nice steps. Okay, so let's find, well, what I'm really looking for is wrap old self expression. I don't think it exists now. Okay, here, this one does sub expression. Oh, okay. So this one can be sub expression parser. 1 parend. Okay, so it is 2 sub expressions, so it's like that. Okay. All right, and we didn't see this. Okay, so let's just look for wrap old. Really? We got rid of all of them? Oh, that's so good. Wrap old. Make sure I'm not. Good. Okay. Then at this point, let's find expression. Expression parend. Oh, I was wondering if you could leave those in there like that. I don't normally do it, but okay. Keep looking. Okay, nobody should be referencing this now. Except, well, I shouldn't say nobody. The factor does indirectly. Yeah, parenthesized expression, some sort of function call, variable, array reference. This one is another variable, predefined function, and predefined, and this should be user defined. Okay. Let's see who calls this. Should be in one place. Yep. So this is factor. Let's see who calls this. Okay. Left and right. Okay, so this is power. Okay, so we can get rid of factor. And then parenthesized. Numeric factor, variable. Not form predefined, we just wrote that. Ugh. These catches are really kind of ugly. Okay, predefined function call. That's the old parser. Okay, type check we'll keep. Is compatible we'll keep. Form we'll keep. The user defined function call we'll get rid of. Okay. Now, yeah, that leaves a couple places. That we're calling factor. Okay. Which is power. Nobody should be referencing power except above. Left, right. Let's try this one. Power. Term. Okay. Right. So term, same argument. Nobody should be calling that except the one above it. Self-expression, I think, maybe. Term. Right. No one should be calling this except the one above it. This, the one above it. Negation. And, okay, let's just take them all. There's or expression. Self-expression, term, power, and that should do that. Okay. Let's see if we got everything. Expression. Okay. That's the one we want to get rid of. Now, there is still stuff in here. Okay, but we got rid of the old expression parser. Eliminate old expression parser. Okay, that's definitely a step forward. Okay. And we have no wrap old. Okay, so delete when the wrapper test goes away. Well, let's find wrap old more broadly. Okay, so we got this class. Nobody's using it now. Okay, just the test. Okay, so let's delete wrap old. Move that to trash. And wrap old tests. Wrapper tests. Okay. Yep, it's just that. Delete that. Okay, move to trash. All right, this should still work. Slightly fewer tests. Okay, delete when the old test goes away, remove when wrapper test goes away. Okay, we need a couple of old style functions to call. Okay. Okay, let's take that. So eliminate wrap old and its tests. Nice step. That means we've really tipped over. We're basically running just our new parser now. Use the new expression parser everywhere. We did that. Eliminate all wrap old calls. We did that. Okay. These are, well, I want to do them, but I think there's other stuff to do first. We got to look at the cleanup side of this. Okay. That's fine. Okay, we would like to pull this out just like we did this one. Who calls this? I think we got rid of those too. So now I'm just looking for dead code. I don't think anybody's calling this anymore. Oh. Okay, who are you? Require. Anybody calling that? No. Okay, so what was I looking for? Next token. Should be the only one. Oh. He's not updated. Okay. Index of. That's an interesting one to get rid of. All right, let's make sure everything's good. Okay. All right. So parse calls single line. This is a helper function. Index of, okay. We're using it still, just to verify. Yeah, we'll try and get rid of that. And we might have one in our statement test too. Okay. Match and one of those are, they're basically parsers that we've defined. I don't know if we're certainly using them in here. Okay. Require float type. I believe we're using that. That looks like a new style. Yep. Oh. What? Okay. I'll just go through and see where we are first a little bit. This one should be here. Oh, something's wrong. Let's find text. Yeah, okay. Old parser. Require float type. 2 versions, 3 versions. Yeah, statement parser uses those. Oh, uses its own. Okay, that's the explanation. Require float type is for statements. I can't believe none of our expressions can say require float type. I'm going to hold off because I think we may need it. Same thing for matching types. Who uses that? Statement parser. Okay. They use the new style. Require float type, the old style we got rid of. I should say, I assume we got rid of. Let's check it. No, nobody's using that. Require float types. That looks old style. Yep. Okay, let's run. Okay. Remove more dead code. Type checking. Okay, this is our giant expression parser. Ugh. Okay, form numeric binary expression. So similar. Like maybe this should be pulled out for. Expressions number matching binary. Oh, this is just for sub-expression. There's only 2 expressions. Okay, unary expression. Predefined function call. That's definitely new. Type check. I guess we called this. It's a question to me whether it's the best way to do it. Yeah. Okay. This I like better. The bool is a little weird, but I mean, often when you return a Boolean, it's probably an indication of something else off. But I just want to say if the parameter types are compatible with the argument types, then we're good. And that basically works. Okay, form user defined. All right. So let's see. Do we have any changes? No. Okay. Let's take the to-do. Make variable tokens another type. Okay, so I guess we're doing eliminate unused old style parser code. Okay. Now, I think there's still this. Does anybody reference this? Not very much. Token. It's just grabbing the random token. Yeah, this is why I want to change this thing. Okay. Yeah, so I think I want to split this into two conditions. Boy, I almost just want this to be a condition. Parameter types count equals arguments count. Okay, let's extract that. Parameter types count. Sorry, if parameters count is less than or equal to argument count, that says we have more arguments than parameters. If the parameter count, let's say, is 5, and the arguments is 4, that's okay. If it's 5, that's okay. I'm trying to guess. This is really too many arguments, right? If the arguments count is greater than parameter count, yeah. So I don't want to reverse this. I think this only happens. I think the message is a little misleading. I think it should say function called with more arguments than parameters, or than available parameters, or something like that. Function called with too many arguments. Maybe that's even better. If the arguments count is equal to parameter types count, that's not a problem. Okay. If the argument count is greater. Okay, so I'm reversing these. I'm not flipping with a not, I'm just flipping the way it reads. So I'm going to say if argument count I'm trying to make a better reading for me anyway. If argument count is greater than parameter count, okay, that should pass as is. Okay, so this is kind of flip direction of comparison. It's a refactoring. It's not very common. Okay. All right. Function not called. I would just say function called with too many arguments. And somebody should be complaining about this message. Oh. Okay. We are missing a test case. Okay. If the arguments count is greater than parameter type count. Okay, let's find. This is, who calls this? Predefined. Certainly does. Okay, and let's find a predefined test. Range function. I don't think we want a check error kind of case. Do we have that here? Okay, let's make it's really predefined called with too many arguments. Come on. Oh. Check expected error. The string is 1 print val x comma 2 quote, and we're expecting this message. Okay, predefined called with too many arguments. Expected error 1 print val x 2. It should only take 1 argument. We should get that. Okay. Let me put this back. Parameter types count is 1 is less than 2. We should get the error. Okay, let's make sure we're getting there. This is predefined. Okay. Take this breakpoint out. And this call should have thrown error. Arguments has 2 values. Parameter types has 1 value. Okay, so let's step in. Parameter types 1 is less than 2. Okay, oh, it's token again. Oof.
Did you hear a knock?
No. Okay, so token, yeah, again, token gets set forward and back as the parser goes through. And really it's not really anything at this point. We don't use it. It's just used in this code, but the token itself is not being maintained right now. Rappold used it, but this okay, what do we do about it, right? We get the message. Okay, let's make sure it calls the throw. Okay. Step. We should be in a catch. Okay. Let's print remaining is 8. Okay. Function not called. Okay, that seems good. And start index -2 is 6, which is plenty. Let's check where it is. 0, 1, 2, 3, 4, 5, 6. Okay, so it's pointing right there. We got the error in our hands. Okay. And predefined call fails at position 6. Okay. Now this is where, so this whole thing fails. That should return the message there. Let's make sure we're using OR. Yep. Predefined failed. It should. What error? We got no error at all. That's the weird part. The tracing from here gets really ugly. Okay, target. Wait, why is this a success? Okay. Or else. If index equals start index. Why is okay? That's the parse for expression. Parser 2. This is just or else. Parser 2. I wish I knew what parser 2 was. I don't think I can tell from this. Yeah, it's just too complicated. Name parser. Okay, so this corresponds, I think, to this. We should be able to see the name in here. Okay, default message. Expected start of expression. Okay, let's continue. Why am I back here? Failed, should have thrown error. Okay. Well, these are hard to debug with this new combinator style, I will say. We expected an error. We didn't get one. Let's try different. Let's try LAN or SQR. Okay. I'm expecting the same failure. All right, we've been going for an hour. Let's take like a 5-minute break and we'll come back and figure out what's going on with this thing. It appears, I mean, what it appears to me is we're triggering this error. We said it was at position 6, which sounds plenty far along. We know if you were back at the start, like if you have alternatives and you fail at the initial position, it just takes that default name thing. But I don't think that's what happened to us. All right, but let's take a 3 to 5 minute break and come back, tackle that. We'll get through it. Thanks. All right, welcome back. Okay, so we wrote this new test. Check predefined calling with too many functions. Square root just takes one numeric argument. And we expected to see a function not called with correct number of arguments. Instead, we're seeing no error at all. All right, let's restart this. Okay, so I want to do, here's form predefined call. It should be called once for square root. So let's run this test. Okay, and we expect to step down and end up here. Okay, so in failure 263. Okay, and let's look at the message. Okay, so the message says function not called with correct number of arguments. So that tells me the failure is being caught. Okay, which is a good thing. All right, let's look at remaining. Here's remaining token, new end of line, and end. Okay, so that's what we expected. The end of, let's see, the start index should be 8. Yep. Okay, and we're doing -2 because the previous character was a right parenthesis. If it passed syntactically, this is a semantic check that comes out to the syntax checks. So it had a right parenthesis, and whatever came before the right parenthesis was not right, and that position is 6. Okay, in the tokens. Let's see what token is just for. Should be nothing. Yeah, it's the line number. Okay. Oh no, it's the SQR. Why is that moved forward? Oh, token's a local variable. Okay. Okay. Let's try print. Ugh. Self.token. Yeah, line 1, column 0, integer. That's the line number. Okay. So we're here. We're returning this failure. We're in a form defined call. It's all part of a bigger parser. We're going to get into how the parser combinators find their errors and all that stuff. Okay, so form predefined call. That's the predefined function parser. Predefined function called parser is called here. It's an alternative. What should happen with an alternative is if you fail with a start index, let's see. Yeah, if you fail with a start index bigger than you started, then then you are deemed to have found an error. If it's the same as the start, we try the next thing. Okay, so in other words, if you looked at the first token and you couldn't match even that, then you try the next alternative. But if you match the first token and then go further, that should be fine. You get here, you won't even really get here. This parser should detect that it's good enough. All right, so let's step again. Okay, now this is our check. So with check, it succeeded in parsing. The syntax is right. And then whatever kind of, assuming the syntax is right, we just call our checker function. In this case, the checker function is returning a dot failure. It returned that message about the wrong number of arguments. Okay, so let's get out of this. Okay, now this one is the or else parser. So that should correspond to this. Okay, so it probably corresponds to this or else. So we called parser 1 and we're parser 2. Parser 1 failed at the front. Okay, so since parser 1 failed without even consuming anything, it just failed at the very first symbol, we go ahead and call parser 2. Okay, and so we're going to return the result of that, which is our failure still. Okay, now we're in or else again. Okay. I think we're in this or else. Is that right? Yeah, I think we're at this one. So let's see. This failed. We called that. Now I think we're at this one. Match already failed, so we called this. So we got to go 1, 2, 3 more to get out of these or else's. Okay. No, I'm going to take that back. I think we're working our way down. I think we're at the user-defined function called parser. All right, and we can probably tell if we step in. Let's go ahead and step. Now, I think our okay, we have a failure. Input equals start index. If it says true, then we're not on the one I think we are. If it just returns the result, I think we are okay. Yes, okay. So I think we just did the following one, and now we're getting the name parser. Step over, name parser. Okay, and this one, yeah, we got a failure. Location, which failure are you going to return? Are you going to return the one that you got back, or are you going to return a default message? We should return this one. Okay, so location is 6. Input dot start index is 2. So 6 is greater than 2, so we're going to take this failure. So far, so good. Okay. Return that. All right, now we're in the end then. Okay, so our factor parser returned the error message we just had. Okay, now factor parser is called by, wait a minute. user-defined function called parser. So we just did a print expression. So this should just come out. It should probably go in here. And tokens.count equals 0. Well, I don't know. We got a failure, so I'm a little parse 1. Let's see where it goes. Failure. Okay, so we're still in our failure. Let's look at the message. Function not called with correct arguments. Okay, so our and then goes on. Okay, now we're at the other check. Let's go here. Failure. We already failed, so go out. Okay. Yeah, so we're working our way up the tree. Negative parser term, expression relation, and, or, and so on until we get to the end of expression. Where can I stop? Okay, our program was a print. I don't know if the statement parser. Print parser. Okay, so it matched the word print and then 0 or more semicolon expression parser. So it should get here. Now maybe this is the wrong. I'm thinking it should get here. Now this is a challenge because if you say many and you don't have one, okay, we're not going to get this far though. I'm trying to think if there's a place I can break or look. This is certainly the first suspicious thing I've seen because I think these expressions, they're just going to pass this value, the failure up all the way to expression parser, which statement parser is calling. So I think what happens is it gets here and gets a failure. And I don't know if it... And it only calls this if it succeeds, so we're not going to see that. Okay. So expression parser, we expect to fail. Yeah, the question is, what does this thing do? So this is many parser, I think. Many, okay, there's the star. Failure. Position less than last for many. Oh, so okay, let's continue to there. Okay, now let's see if we can see result. Still good. Okay. If failure, and what's position? Should be the 6. Oh. I don't know if I can step over. Okay. 6. Last remaining has 8 values, so that's probably a lower value. 2. Is 6 greater than 2? Yes, we should return the failure. Okay, let's make sure we do. We do. Okay, so where'd statement go? So we're here. We're saying this returns failure. Right. So this failure says you made progress into the contents of the repeat. Therefore, you're not a pure failure. You're a syntax error. If I just got there and didn't see it when I thought I could see it, that would be acceptable. I'd return success. But if I really did get halfway through parsing it, then it really did find an error, and that's the case here. Okay, and then let's lock this in. Okay, now I'll bring up statement parser. Lock it in. Okay, so we're at this. This thing's going to fail. So this thing won't run. The print parser as a whole should fail. Okay, let's step. Okay, we're in the many. Now we're in the and then. Okay, and this is the pure and then keep right. Okay, so where's statement? And then keep right. So that's this one. Okay, so the first part, the print statement itself succeeded, and now we're trying to keep the one on the right. This thing got a failure, so it should come here to 216 and return a failure. Okay. Now we're in the pipe. Pipe should say there was a failure. I just fail. Okay, so step. We ran the parser. It failed, so we just fail. And the message. I think I lost my scope. Yeah. Can I still see result? Okay, I've still got the same message. Now we're in or else. Okay, so statement parser. We got to find who calls this. Well, we know what it is. It's this giant thing down here. And so I think we can go into the name parser. Name. Let's break here. I think this is where we should be next. Okay. And we can see a result. Should be the same. Okay. Failure 6. Okay. And then let's look at input.start index 1. Okay, so this should keep the failure in 32. Okay, return that. Now we're in an and then. And then, so who calls this? Statement parser. Statement parser. single line parser. Okay, let's go in there. There's statements parsers. Okay, and this is keep, and then element array. And then element array. I don't see this being an array. This matches a line number and a statement. Okay, so we're still gonna keep this. Return that. Okay. Separated by. Well, that whole thing returned a failure. Why are you in bind? Bind, return the parser function. And then again. Well, result 1 is successful. I don't know what that is. Target 1. Remaining one looks right, but target 1 looks weird. Okay, step over. Result 2 is a failure. Function not called with the correct arguments. Okay, it seems to be bubbling out. Oh. Okay. Another and then keep left. I don't know if I can tell what this is. We haven't caught this one yet. Result 1 is our failure. Okay, so we're going to bubble that out. Now we're in the pipe. That should just take the failure. Yep, bubble that out. I don't know why we're in the bind. Oh, we are a bind. I guess this is showing us where it was put. Okay. Parser. We return the result. Okay, single line. It's a failure. Error index 6, messages function not called. Okay. Okay, 6 column 14 integer. Yeah, I mean that second argument was an integer, so I think that's what that is. Floating value 2. Okay, let's make sure. Where did our test go? Yeah, that's the 2 here. Okay. All right, so our single line parser seems to be failing with this message. Okay. Well, that's a lot of work to get here and find out that single line parser really is producing an error line with the token line, column, and message. Okay, but let's go out of here. Who calls single line? Well, that's parse and syntax analyzer. Oh, really? Okay, we're at a runtime thing here. Wow. Okay, so this is when the program first runs, there's what they call data statements that have all these, they're sort of like input values, but they're pre-populated input values. And it runs through, parses every line, pulls out the data statements, grabs up the data. This isn't even really doing the real function yet. I don't know who's his caller. Let's find that. Interpreter gather data, interpreter.run. Okay. It is doing that. Predefined functions, locations. I guess, oops, let's break here. We'll continue to there. We're back at parse. Name. I think we're just repeating everything we already did. Run loop. Okay. Step into. Let's go here. Okay, so let's look at parse. This should have our error message in it. Okay, what the heck? Let's step in. Oh, I just stepped over. Well, I expect should run to be false. Okay. Should have thrown error. I don't know if that's true. Okay, the interpreter run loop. Okay, it parses the thing. It tries to do a step. Let's see what happens with step with error. Interactor.append. There's no error message thrown. Line 114, not called with correct number of arguments. Done is true. That's why we didn't proceed further. Okay, so okay, we did a step. I think my test is making a bad assumption. I mean, runtime errors definitely get printed. Maybe it should throw an error. Try step. Sorry, who called this? It was interpreter tests. Check expected error. Okay. Interpreter error. Get a message. Yeah, we don't capture syntax errors this way. Huh. Let's see who uses this. Okay. That's a runtime error. I think we're only catching runtime errors with these. That's a runtime. That's a runtime. That's a runtime. Yep. 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 That's runtime. Those are all runtime. Yep. So they're happening dynamically. So that's how I know they're. Yeah. Okay. Check expected error only works on runtime errors. Well, how am I checking my syntax errors then? Let's see. Statement tests. Okay. I mean, so what happened is there's a screen, this output interactor thing. That's what shows up on the screen. Let's run. Okay, I'll run this. I don't know if I have a place to display that stuff now either. There it is. Okay, 10. Function not called with correct term progress. Oh boy, so all that parser tracing. Half an hour parser tracing. The problem is not the parser. Okay, it is finding this thing. It's my understanding of the check error thing. I guess the thing you would get. Oh wait, parse. It's really the syntax in the current line. I think you could make a pitch for the interpreter throwing an error when it runs into a syntax error. I think that maybe should be true. Let's do this. I don't. I'm going to do this as a run check and make sure nothing's weird. Print square root 2, run that. Where's my debug? Deactivate breakpoints. Thought there was a way to kill them all off. Delete all breakpoints. Okay, let's continue. Okay. I do print that. Interpreter. Oops. Okay. Well, that question mark and stuff is weird. Now let's see what tests do, just to see what I'm breaking there. If I can make myself happy on the runtime. 2 failures. Yeah, that's different. Okay, I expect a different output, and 14 function not call. Okay, I mean this could be 1:14. That'd be fine. What do I want this to do? That colon space is weird to me, but it's whoever catches this, right? Step. Try that. Run loop throws. Run throws. Who calls run? REPL is the one that we care about. Okay. I don't know how I want to do this. That's the problem. And I really am changing the way things work, and that's deliberate at this point. I'm going to bring a bunch of tests doing this. Well, the same too. Error 10, 7 extra characters. Error. Okay. Syntax error stops interpreter. That is true, but now we're saying it throws an error. I think my check is the bad thing. Okay, let's undo the interpreter stuff. Let's revert this. Okay, where's my test? Interpreter tests. Check expected error is just not the right thing to call for this. Okay, let's run tests. I don't know if I changed anything else. Okay, just the one. How do I check syntax errors generally, though? Something's going wrong here. Statement parser, control flow tests, those are interpreter tests. Okay, let's look at things that aren't interpreter tests. I think I have plenty of syntax tests. There's parser tests. Check error. Well, that's more like it. This should be a parser test. Okay, where did I put that predefined value test? Predefined function test. Let's put that with the parser tests. Parser expression tests, maybe. I think it's more of an expression test. Well, okay, here's enforces types. All right, let's put it right here. And call check error instead. Goodness. Okay. Yeah, I feel foolish about that, but that's the way it goes. Let's find this text again. That's in. Well, let's close some of this stuff. Whoops, probably could have kept some of those. Basic parser. Find this string. Nope. What was the text of that? Function not called. Okay. I think I want to say function called. Well, let's do it properly. Okay. Okay, basic. Here's the parser tests. Okay. Function not called. I want to say function called with too many arguments. Okay. This function called with too many arguments. Okay. Okay, and then who called this? Oh, and I want to flip this around now. Arguments count is greater than parameter count. Okay, now I want to know who calls this. Selected symbol, 2 places. Once for form predefined call, and once for user defined call. Okay. I guess what I like these. I sure would like something that was just this. And then something that was this. And these throws. Okay, I don't know what I want to do in terms of this. Eliminate old style parser code. We've almost done that. Okay, where is it missing? Well, we got balled up. We originally got into this because of token. Token. Okay, does anybody reference this? I think there were 2 places. Right, these. And both of them, the token gets ignored on the way back out. Okay, so let's just do token end. So I'm just putting a dummy token in because I ignore it. Of course. Okay, fine. We're going to get rid of it in a minute, I think. Or hell, at some point. We don't need tokens. Okay, so if I comment this out and run. Okay, that is good. Okay, now what about token index? I think that might be used. Not sure. Nope. Tokens is, though. That's the array slice. That's the stuff we're parsing. Okay, so, whoops, run test. Make sure nobody out there's playing with that. Okay, yeah, they were using it for the wrapper. Definitely needed it too. So, remove unused token and token index. Okay. What else have we got? The old style parser code. I think we've done that. No, we've mostly done that. Okay. I'm going to leave a gap that we still have, let's say, remaining. Okay. Make variable tokens another type. I think I want to, I don't know, require float type, not used. Why not? The thing is, I thought it should be used for expressions. Like, the problem is, yeah, like these. So if you have factor parser and it just goes to a string, that's acceptable. But if you have an exponent, then all of a sudden it doesn't. And I don't have a good way to express that requirement. But maybe I'm overloading form too much. That's what I think. So I think at this point I'm critiquing the quality of my new implementation more than I'm not doing replacement anymore. Um, so maybe what I should do, I think what I should do is, I don't know, if I extract the expression parser, there's just not much left. I guess they're going to need their own match. Do we use this anymore? Ooh, okay. Let's put a 0 there. Okay, it can't happen. That'll just sort of fade away. Maybe a 1. Okay. And this goes away. That's a good thing. Okay. Now this. Right, this stuff is... Okay, but somewhere we're calling form. And here is variable parser. It's kind of a big deal. Yeah, I think I can do some better job on these semantic expressions if I work at it. There's okay, type check. Gosh, this I almost think I can just do this in place. Like, this is the part I care about. Maybe I can... Let's... Okay, let's see what we say we're doing. Eliminate remaining old style parser code. I think we're going to say improve use of checker methods. Okay. Yeah, let's get this out. This is extract method. Oh, come on. Yes. Okay. What is he doing? He's saying, this is like has too many arguments. Arguments in the parameter types. Okay. And if you have too many parameters, arguments, return this junky thing. Okay. Now, I can pull this up, right? Whoever calls this could do this instead. Type check. Here's type check. So the first part, so I'll put it beforehand. That's practically inlining this thing. Okay, now I had another type check down here. Okay. And I don't know if we can combine them. We might be able to. Has too many arguments. Well, this is argument, and the duplication is going to go away soon, but number. Okay. If it has too many arguments, argument number. Well, that can't even happen. We're guaranteed one expression, so this doesn't care. Okay, now let's look at the rest. Okay, I would like to turn this into one true or false statement, and at the end, if it's true, then I throw. Okay. Why it's a try? It's because of this. Okay, so zip for each not compatible. I want to say something like zip parameter types and arguments. And I don't know, I think I'm better off doing them the other way. Arguments, parameter types. Okay. Let's flip this around and then improve it. For each argument parameter type. And again, I kind of want to switch these two. If argument is compatible with parameter. And that looks like a function on types too. All right, so I got those like that. That's certainly the same. This goes away. We'll keep that for reference for a minute here. Okay. Now, if I do for each not is incompatible. See, I want to say like dot satisfy, all satisfy some predicate. Okay. I'll say result equal this if result, well, no, this is all are compatible. All arguments are compatible. If not, then I do a throw. I'm trying to get rid of this. Okay. For all arguments, all satisfy, and this is argument parameter type in. Okay, so I got the pair argument and parameter type, and I want to satisfy is compatible. Parameter type argument dot type cannot convert value. Okay, if they're not all compatible, I'm going to report an error. Basically, it's on the expression type mismatch. Okay, now this we pulled up. Okay, so I claim this should be the same. Okay, I'm happier. Okay. Now my braces look funny. Let's make sure this is okay. Type check. Okay. All arguments are compatible equals zip. If not. All right. Now I kind of want to inline this. So we had a type check up here. And then if not, we're throwing some sort of error. Okay, the type mismatch. So if not, return a failure. And I guess that's this again. Structure index to 2, and the message is type mismatch. Okay, and so this is no longer needed because I just did everything. Okay. Type check, type check. Okay. Now let me do the same thing down to the other one. Well, that's clearly overkill. Parameter type is dot number. And argument is that. Okay, I don't need any of this stuff. Parameter type argument dot type. Well, that's this. The message is type mismatch. Okay. That takes everything that type check did. Okay. And catch block is unreachable. Yeah, both of them are probably. Who throws parser here? Oh, this thing does. Oh, well, yeah, if this fails, we should do a failure. Failure, and the message is this. Okay. Now that should all pass. I don't know, I'm kind of doing two at once. All right. Now, certainly this goes away. Catch block is unreachable. That's what we wanted. Okay, we don't need a do anymore. Do. And all these catches. We got rid of the can't happen thing, so that's progress. Okay, and then same thing here. The catches. Did I get an extra? Okay, so that should all be okay. I don't know, I'm just going to say improve type checking code, mostly inlined to eliminate do catch. Okay, so now I don't think anybody's calling type check anymore. Find symbol, no. Okay. And then is compatible. Okay, let's see if there's anything else first. Okay, let's reformat. Okay. If not compatible, argument type. Return failures, type is match, otherwise return success. Good. That looks better to me. This one, I think the arguments are backwards. At least the way I'm thinking of it. Okay, and then oh, interesting. This should fail some tests, I hope. Yeah, good. Okay, because I got to find the call sites of this and swap their arguments. Probably a case where I should be naming them, but I think I'm going to try a different approach in a minute here. Selected symbol in workspace. It's compatible. Okay, this should be parameter type. I just think it's more natural to say a type conforms to an expected type. An argument type conforms to the parameter type. Okay, these should now pass. Let's swap argument order on is compatible. Okay. Now, is compatible is probably, well, what I notice is it works on types. It doesn't do anything other than work on types. So all it's arguing, it's a pure function of its stuff. Okay. And so I think I want to change the name. I want to say conforms to. Let's rename that. Conforms to. Okay. And now this is feature envy. Everything on here is a type. So let's move it over to type. Nothing about it is concerned with our class directly. Okay, we haven't got any functions there yet. Okay. Now, this argument type is going to be self here. Okay, I think since I have two call sites, I will just take the chance of doing it right. Okay, so argument type. Well, let's swap this too. If self equal no, let's not. Let's do that in 2 steps. Okay, argument type is self. Let argument type equal self. Okay, now the call sites on parser conforms to. I'm gonna say this is really argument type dot conforms to parameter type. Okay. And make that public. Okay. Let's run tests. Okay, so rename is compatible to conforms to move to type. And I guess that whole thing is a refactor. They're all a little squishier when you don't have true IDE support. Okay, I would love to just go right click, refactor inline. Okay, but I can't. So I will do this manually. And we'll find these two conforms to. So this is really, well, argument type dot conforms to parameter type. Okay. I think that's an improvement. And this is argument type dot conforms to number. Okay, that should be fine. Okay. Okay, that I like better. Okay, that is improve use of checkers. Yes, that's what we're doing. Okay, has too many arguments. Let's. Okay, let's move this function up a little. Okay, it has too many arguments. Then I think this one, arguments are compatible. I think I want to encode that in a function too. So let's take this. I don't worry about names just yet. Okay, well, there's something in there. It returns a Boolean, and it's this. Okay, so arguments, it's really this again. Arguments of type expressions, list of expressions, and parameter types are lists of types. We're going to convert those arguments to types, make sure each one conforms to this. Okay. And then this. I guess all arguments are compatible is enough there, yeah. Okay. If they're not compatible, return a failure about type mismatch. Okay. Okay, so if you understand what it means to have too many arguments, which is a combination of expressions and types, and it's an arrays, I guess I'm okay with that here. And this. Although it's... Can I put it on function? Well, it would be nice if I could just ask the function. It's a result type, right? So the result type, I would love to ask that type Are you compatible? Are these arguments, actually, I want to ask it, are these arguments compatible with you? And then I don't think I have to do this append missing stuff so much. Okay, I'm going to let it go for now. I think we have the two methods, those two. Okay. Do I have any changes left? No. Okay. Cool. Now I'm still I'm wondering like this stuff. I feel like this is I feel like it's its own thing. Like we're checking it's either we have just a single expression in which case it can be numeric or string, or we have a number that all the arguments have to be numbers. I think that might be its own thing. Okay. Um what we call this is check arguments. No, check operands numeric. If operators check, I don't know. Check operands numeric if required. What if I did that? And I take in this. Well, I'm basically a checker, so I got to be all that stuff. Versus parse result expression. That. Okay, and well, I could, for now, I could just return success with expert token expers and remaining. Right, that would be okay. Form. Let's say this, check operands numeric if required. Do I put that? I guess I put that on every operator. Every binary operator. Wow, I didn't expect that. Oh, they have to be consistent? No. For numeric binary expression. Oh, cannot convert value. Okay. Expression array token expression to expected output type expression. That needs to be this. I don't know. Is this better? That can't do it. This can do it. Okay, this should all pass because I'm not checking anything. But I want to move this part down. Okay. If experts count returns success, well, I gotta return expert token experts. Okay. If it's a failure, if the type is number and all satisfy all sub expressions. All sub-expressions are numeric, then return a failure. Otherwise, return success. Okay, this should still work. If I take this out, whoops, I think I have to take this out. Should still work. Okay, and then I think, okay. Okay. Okay, this then. See, the deal is we should be able to get this simplified. It should just take one of these. We should just be able to take the value and return another value. Okay. It's already type checked and everything, so it should just transform. So result equals that stuff. We just return result. Okay, but they need the other, the simple pipe. Okay, so result, well, let's just return this. Okay, and then the pipes, they lose this. They're not doing any checking, they're just building. Whoops. Form unary should be happy. Form binary. And I'm going to work on these names a little too. Form binary. Okay. I think this is check multiple operands are numeric. Okay. And this is form binary expression. Okay. And that should all work. Okay. All right. That's good. Okay. So I think what I'm hoping for is splitting out the checking from the forming. It seems like a step forward to me. So I think I will do the work to bring the unaries up to the same deal, and then we'll move forward on the rest of this. So I think what I'm doing is split semantic routines, checking versus construction. Okay. And I think we've done this improved use of checker methods. Okay, so we've basically replaced our parser. Well, we've introduced this second parser that fully is the new style, and that's a major step for today. I think I want to do a little more cleanup, and then tomorrow probably we will. Right now we're doing all this as a big strategy pattern. Do the old parser or the new parser. We're going to go ahead and swap those, or sorry, kill off the old parser completely. But rather than doing this in branches, we've done it in separate strategies. So we'll see how it goes. All right. So tomorrow is basically same time, which is 1 to 3:30 p.m. Eastern time, or 6 to 8:30 p.m. UTC. Thanks for joining. Have a good evening, and I hope to catch you in the future. Bye-bye.